Good evening, students. Today we are going to discuss about aldol condensation reaction. Aldol condensation reaction. So, aldol condensation reaction. So, what is aldol condensation? When aldehydes having at least one alpha hydrogens are reacting together in presence of dilute sodium hydroxide to give beta hydroxyaldehydes. Beta hydroxyaldehydes, also known as the aldols. Let me write the definition of the aldol condensation. For suppose when aldehydes having at least one alpha hydrogen, one alpha hydrogen reacting in presence of dilute sodium hydroxide to produce beta hydroxyaldehydes, also known as the aldols. So let me write the reaction. For suppose reaction, this is the reaction. So here CH3 C double bond OH and again other mole of CH3 C double bond OH. We are taking 2 moles of acetaldehyde. So in presence of dilute sodium hydroxide, it will produce as CH3 CH OH CH2 C double bond OH, CH2 C double bond OH. So this is said to be beta hydroxyaldehyde. It is said to be beta hydroxyaldehyde or also known as the aldol. So beta, why? Because for suppose here in this case, what is alpha hydrogen? So for suppose now here, so the C double bond O group is said to be electron withdrawing group. The carbon which is present or which is adjacent to the electron withdrawing group is said to be alpha carbon. Here the carbon which has hydrogens, the alpha carbon which has hydrogen, those are said to be alpha hydrogens. So here 3 are the alpha hydrogens. Here also 3 are the alpha hydrogen. Here also this is the alpha carbon, this is the beta carbon. So it is said to be beta hydroxyaldehyde. That's why, or aldol. Simple general name is aldol. So this is the aldol condensation reaction. Let me explain what is the mechanism in this case. For suppose here, so mechanism, when we write the mechanism, so first of all, CH3 C double bond OH, CH3 C double bond OH. So for our convenience, I am writing carbon, hydrogen and this is the hydrogen. So this is reacted with OH minus, which is coming from the sodium hydroxide, dilute sodium hydroxide. So that was acting as a base here. So base can abstract the protons and it is eliminated as the water. It will forming CH2 here minus charge. Only proton is eliminated. These electrons are same. CH2 and C double bond OH. Right now this carbon center is acting as a nucleophilic center and this was reacted with other mole of CH3 C double bond OH. Right now this center is said to be electrophilic center and this center is the nucleophilic center. So there is a new bond between these two. Right now it will forming as CH3. So at the same time these 5 electrons are moving on to the action CH3 CO minus and this CH2, I am writing that hydrogen below side and this CH2 and this was C double bond OH. So next on water, why? Because we are taking diluted sodium hydroxide and that water is there. So protonation takes place on that content. It will forming CH3 COH and this is the hydrogen and this was the CH2 and C double bond OH. So this is said to be alpha beta hydroxyaldehyde, beta hydroxyaldehydes. So Why? Because this is the alpha carbon, this is the beta carbon. On beta carbon, OH group is present, na? So that's why it is said to be beta hydroxyaldehyde, general name. Okay, na? So also the IUPAC name of the compound is, for suppose 1, 2, 3, 4. So on third carbon, OH group is present, means 3-hydroxy butanol. 3-hydroxy butanol is the name of the product. Thank you.